to the next part of STOY. So we have mole ratio. So when we say mole ratio, class, this is to identify how many moles of product are formed for a certain amount of reactant. And then the number of moles of a reactant needed to completely react with a certain amount of another reactant. So this is mole ratio. So this is easy. However, you need to have a balanced equation. So remember, the first step is to always have a balanced equation. So we have here nitrogen and ammonia. Look at our coefficients. So our mole ratio, class, is the mole ratio is the coefficient. So nitrogen here, again, if it is not written, meaning it is equal to 1, is 2. We have ammonia, our coefficient here is 2. Therefore, our mole ratio is 1:2. Reactant and then product, it will be 1:2. Next, we have our hydrogen here, and then we have our ammonia. Okay, look at our coefficient here. In our hydrogen, we have 3. And then in our ammonia, we have 2. So therefore, this is our mole ratio. Okay, so now let's go to the reactant. We have nitrogen and then hydrogen. So N2H2, look at the coefficient. Our nitrogen is 1 and our hydrogen is 3. So this is how you find our mole ratio. Just look at the chemical equation, but keep in mind, it has to be balanced, okay? Any question about mole ratio? Thumbs up if you don't have any question. Okay. So let's proceed. So by step 2, we have to convert a given amount of the reactant into moles. So before we go there, we have to first find the molar mass. So from our previous lesson, we already know what is a molar mass, and we also know what is the percent composition and how to compute for it. But let me clarify this term. We have the molar mass and the molecular mass. Okay. So the molar mass versus the molecular mass. So what is the difference? Is this the same? Okay. So for example, we have here phosphoric acid. So let's write the molar mass and then the molecular mass. Okay. So we have here the molar mass, hydrogen, phosphorus, and oxygen. Okay, so for our molar mass, the number of atoms, so we have 3 here. The subscript is the number of atoms. Phosphorus, we don't have, meaning it is 1. And oxygen, it is 4. So times, times, times. So look at your periodic table and let's see the atomic mass of hydrogen. So hydrogen class is 1.008. So let's use 1.01. So round it off to 2 decimal places. For our phosphorus, that will be 30.97. Then for our oxygen, that will be 16. Now let's go to our molecular mass. So it is the same. So 3 times 1.01. 1 times 30.97 and 4 times 16. Okay. So the difference between these two class, okay, so the difference is its unit. So grams per mole, and here we have AMU, and AMU. In previous lesson, we used AMU as its unit, so I changed it to molecular mass. So here we have our molar mass and molecular mass. So when we add this and multiply, so multiply first, then add. So 3 times 1.01 will have 3.03 hydrogen, and we have 30.97 phosphorus, and oxygen we have 64. So grams per mole, and we have grams per mole. Okay, so when we add this, class, can you add and put the answer in the chat box? So for here in grams per mole, our molar mass, can you add it and write in the chat box? We have an answer of, what is our molar mass of? Okay, thank you, Marvin. That is correct. So it is 98 grams per mole. And here we have 98. Oh, okay. So sorry class, hindi nakikisama yung aking gadget ngayon. Okay, so let's write the atomic mass of phosphoric acid is 98 grams per mole. Or we can write it this way, 1 mole of 1 mole of phosphoric acid, PO4, is equal to 98 grams. So this one, class, is what we'll use in stoichiometry later on when we solve the limiting and the excess reactant. So the difference between the molar mass and the molecular mass will be its unit. Okay. But on how you solve it, that will be the same. So now that we know the mole ratio, now let's proceed on how to convert the given amount into moles. So it will depend in the problem. So some problem, class, the amount is given in grams and some are given in moles. So you have to convert it and do not be confused. Okay. For example, we have here how many grams of zinc are in 0.356 mole of zinc. So we have moles to mass because the mole here is already the given. So let's write given. Okay, so our given in the problem is 0.356 mole of zinc. And then, next thing that you need to do, the second step, is to check our periodic table. So look at the zinc, its atomic mass. So what is the atomic mass of zinc? Zinc. So it is 65. What's its atomic mass? Okay, so it is 65.37. So 1 mole of zinc is equal to 65.37 grams. So this is how you create the molar mass in this type of conversion. Okay, so let's write the given 356 mole of zinc times, remember that we need to find the grams. So therefore, our grams is at the top or in the denominator or in the numerator. So this is the gram and this is where we write the mole. Why it is in the denominator, our mole? Because we want to cancel it out. And we need to remain the grams or what we need to find. So the grams is 65.37. So 0.356 times 65.37. 65.37 times 0.356, we will get an answer of 23.27 grams of zinc. So this is how you use our periodic table and the given in converting moles to mass. So how about if it is in reverse? So the given is mass and we need to find the mole. So same process, write the given, so or note the given from the problem. So our given is 6.46 grams of helium. Here, we need to always check the atomic mass. So 1 mole of helium will have what? What is the atomic mass of helium? That will be 4 grams. So now that we have the conversion, let's do the conversion factor. Okay. 6.46 grams of helium times. So now it is grams, therefore our denominator is already in grams. So just copy 4.0 from our conversion and then 1 mole of helium equal to, cancel out the helium grams, and then let's divide. So 6.46 divided by 4.00, we will have a mole of 1.62. A mole of 1.62. So 1.62 mole of helium. So any question about this one? Clarification? Confusing? So if not, thumbs up.
Miss,
Yes po.
doon po sa final answer po sa zinc po, yung 23.27, pwede po siyang i-round off po, like 23.3 grams po. Or
23.
kailangan po laging 2 decimal point po.
Okay. So it is a practice in college because professors always use 2 decimal places. So therefore here in our activity or in this lesson, we need to use 2 decimal places already. Okay?
Okay po, thank you po.
Okay. So 23.27 grams. So 2 decimal places always. Okay, now that we know how to convert moles to mass and mass to moles, let's do this. So, atoms, grams to atoms or molecules. So, some question class, they use molecule, but the correct term is atom. So, to use or to find the number of atoms, we need to use the Avogadro's number. It is 1 mole is equal to 6.02211415 times 10 raised to 23 atoms. But we will not use this as it is a lot or a lot of numbers. Okay, therefore we will just use 6.022 times 10 raised to 23. Okay, because there are calculators that cannot compute in this kind of big numbers. So we will just use this number. Okay, so this will be our constant always class. All of our element in the periodic table has this amount of atoms in the element. So each element has this amount of atom in each mole. Okay, so now let's continue. Write the given. So our given is 16.3 grams of sulfur. And then, look at our periodic table. Let's go and write 1 mole of sulfur. And our sulfur here is, again, it is 32.06 grams. So now that we have our mole here, now let's convert it to mole and then mole to atoms. 16.3 grams of sulfur times. As we know, we want to cancel the grams and we want to find the mole. So we will put grams at the bottom or denominator and then just copy 32.06. And then for our mole, so we will put it in numerator. So now that we have the mole on top, or denominator, sorry, numerator, on top, numerator, and this one class, here we will use this conversion. So 1 mole of sulfur is equivalent to 6.022 times 10 raised to 23 atoms. Is equal to, okay, so this one is tricky. If you have old calculator like mine, so you have to input 6.022 times 10 raised to 23. So use this X class, if you can see. I hope that you can see. The X one that has exponent, a blank exponent. Just click it and then we'll have 10 raised to 23. And then we'll have, okay, so let's answer this one. So this one is 3.06 times 10 raised to 23 atoms of sulfur. So this is our answer. So still you have to round it off to hundreds place. So did you get the same answer, class, in your calculator? So let's have an activity. Okay, so let's apply what we've learned a while ago. So remember, the first step is to, okay, it is to write the given. Okay, so our given here is 87.3 magnesium. And then, let's write our conversion of mole of magnesium. 1 mole of magnesium is equal to, look at the atomic mass of our magnesium. So it is 24.31 grams. So when we convert it, class, let's write the given first, which is 87.3 grams of magnesium times. Again, we need to cancel out our grams. So grams, here 24.31 in the denominator, and the numerator will be 1 mole of magnesium. Is equal to, so you just divide and you will get an answer of 87.3 divided by 24.31. So we will get an answer of what? So what is your answer, class? Can you 59 mole of magnesium. Now let's proceed. Okay, so number 2, number of grams of lead in 12.4 moles of lead. So let's write the given. So 12.4 mole of lead. Then, let's look at the conversion. Let's create our conversion. And then, look at the atomic mass of lead. 1 mole of lead is equal to the atomic mass, which is 207.2 grams. So, when we multiply this one, so we have 12.4 mole of lead, and then times, okay, remember we need to cancel the mole and we need to find the grams. So our gram is at the numerator, so which is 207.2, and then mole here is at the denominator. So 1 mole of lead. So when you get the answer or write the answer, 28 grams of lead. Okay, so now we know how to convert moles to grams and then grams to moles. So let's go to the number of potassium, or the number of atoms of our potassium. Okay. So the first step is to convert the grams to moles and then moles to atoms. So let's write this one this way: grams to moles to mole, and then mole to atoms. And then remember that 1 mole of sulfur, potassium, is equivalent to 6.022 times 10 raised to 23 atoms. So let's compute. And our given is 0.551 grams of potassium, which is our given. And let's write our conversion, which is 1 mole of potassium and its atomic mass. The atomic mass of potassium is 39.10. So here, class, we will get a different answer if we do it this way. So let's first use grams, 0.551 grams of potassium times, again, use this conversion, 1 mole of potassium is equals to 39.10 grams. So 39.10 grams and 1 mole of K. Then times 1 mole of K, potassium, and then 6.022 times 10 raised to 23 atoms. Okay. So how about if we do it this way? So 0.551 grams K times 1 mole of K, 39.10 grams, equal to, then times 6.022 times 10 raised to 23 over 1 mole of K. So let's do this. Let's do this number 1 first. So let's compare the differences of the answer. Okay, so let's compute this one. So 6.022 times 10 raised to 23 times 0.551, and then we will have to divide it by 39.10. So you will get an answer of 8.48, 49, you round it off, to 2 decimal places. Okay, 8.49. Okay, 8.49 atoms of potassium. Okay.